Hi everybody, Mr. Farmer here, and today we're talking about the circular flow, but more importantly, the nominal versus real GDP, and then we're going to end with talking about some of the limitations to GDP in general. Alright, here we go. So first off, just a little practice walk-in. Just kind of check if you can do this on the left-hand side. We got the national income. So you got the computation of employees, rents, interest, proprietors' income, corporate profit, tax on production of imports. You'd add all of those together, but you would not include the gross private domestic investment because that's part of the expenditure approach. And make sure you just understand that. So you end up with the national income. You'd take the national income and put them up at this top section over here. We're going to subtract the net foreign factor. We add in statistical discrepancy. If we stop there, we'd have net domestic product. But next, we're going to add in consumption of fixed capital, and that's going to get us to the GDP, gross domestic product, at the bottom of 9,500. Government purchases part of the expenditure approach. So if you need to review the income approach, definitely do that. Otherwise, let's keep going. So this is the big old circular flow. Quick little couple of things that we are going to mention, just to kind of make sure. I like this image because it talks about the income approach. That's going to be all these green parts compared to the expenditure approach, which is all these orange parts. Okay, so we're going to get a couple of things out of this. First one, the net domestic product is always going to be less than the GDP, so that's just kind of a definition to know. And this is because there's always consumption of fixed capital or depreciation, same term, somewhere in there. And again, GDP minus consumption of fixed capital, and another term is depreciation, equals the net domestic product. So this first bullet point will always be a true statement. Second, disposable income will always be less than personal income, and this is because personal income is just the gross income. Disposable income is what we call net income. It is after you've taken out the taxes, it is what is left at the household's disposal. So disposable income, you might hear net income is kind of more of a technical term. We'll probably use disposable income for that, so after taxes. As far as households, you have inflow of disposable income, and so you have your households over here. You have money flowing in, that's national income going this way, in which case they can now spend money. So they can spend money, they can also save money, and we're going to come back to that statement later on. That's going to be called a leakage in society because it's money that was earned but not spent. Government has different inflows, mostly through taxes, you can see, and then they spend money. So they have the public deficit as well, so that's going to be them borrowing more and more money in order to do that, and then they can spend money as well, so they're going to be part of it. And then the business, so again, the circular flow, the reason why the income and expenditure approach equal each other is because this system is kind of how it works. Again, there's some leakages, like net exports, international flows, you might lose some track of some money there, but overall, that's kind of why it works. And here we kind of have some redundant, so we're going to skip through this. So nominal versus real GDP. This is where we really want to talk about stuff. When economists talk about how well an economy is doing or have they grown at all, they always refer to real GDP. So what's the difference? Nominal GDP, or you just say GDP, is the GDP based on the current prices. Real GDP is the GDP if you adjust for inflationary prices. Pretty much real GDP tries to hold all price values constant. So what's the benefit? With real GDP, I can identify how much more stuff has been produced. So we're going to do a couple things with this, and we'll get more explanations as we go along. So the first thing is we're going to need a GDP price index. Now, a price index is a measure of the price of a specified collection of goods and services, what we call a market basket, in a given year as compared to the price of identical goods and services in a reference year. So a price index says, for the same amount of stuff, how much more expensive was it? And so we have this price index, PI, equals 100 times the value of the market basket in the current year, the year you're in question, and you're going to divide that by the value of the same market basket in a base year, and that's going to be a common base year for the entire data time. Example. So let's say that in the current year, the government uses a market basket of 26 items, just A to Z, just goods A to Z. And in that current year, the total of those 26 items has a value of $1,000. Okay. In the base year, that same 26 item market basket, so again, you want to have the same 26 items A to Z, A to Z. In the base year, the value of those items was $750. So what's the price index? Well, price index equals the 100, because you want to put into that number, times the value of the year in question, 1,000, that's going to be the green number, divided by the value of the market basket in the base year. So when you do this, you'd find that the price index for the year in question is 133.3. Good thing to know, the base year will always have a price index of 100. Why? Because the base year, 750, is going to have the value of the market basket, 750, divided by the value of the market basket in the base year, also 750, times 100. So 100 base year price index indicates base year. So how is the CPI determined? It's based on surveys. It's all about surveys. Given to households, the government creates a list of them. It's about 243 items. There are different lists for different things. And if you want, you can go to the BLS CPI Appendix 2 content of CPI entry levels, and you can see all of them. Some categories are weighted more. For instance, rent is very heavily weighted because it impacts a lot of people. Gas prices is more heavily weighted in that categorization because it impacts a lot more people. Things that don't impact as many people may not be on that list or may not be as weighted. We won't get into that, but it's kind of an interesting thing. Clarification for AP macroeconomics, consumer price index, and the GDP price index, and the GDP deflator for our purposes are interchangeable terms. Yes, there are actual differences, and if you want, you can look into it. It is interesting. They're interchangeable for our purposes. So for all the equations we're about to go over, if you're given one of these, just use them the same way. We will typically do CPI, but the other ones you will see, especially GDP deflator. I do just tend to see that one quite a bit on College Board MCQs and also even FRQs sometimes. So in order to get to the real GDP, we're going to need to do a couple different things. First, we need the nominal GDP, so you'd use the expenditure approach or the income approach or something else. And then we're going to have a GDP price index or consumer price index or whichever version it is. So here's the actual equation. The real GDP equals the GDP, that'd be nominal, divided by the price index in hundredths. Meaning the GDP divided by the price index divided by 100. So just move that decimal over 2 times to the left. So we will definitely be using this one quite a bit and use variations of this. So if you have the real GDP, if you multiply by the price index in hundreds, then you get the nominal GDP. And if you're trying to find the price index, then you can do GDP divided by the real GDP. That would equal the price index in hundreds. So multiply by 100, you get the price index. So you use this equation quite a bit in various different ways. So for example, if the GDP was 15,000 and the CPI is 150, what is the real GDP? Pause, take a moment, think about it, and get back to us. And unpause. You get $10,000. So just plug into that equation. You notice there's a graph down here from the FRED. That'd be the Federal Reserve Educational Department, usually based out of St. Louis. At one point, they're equal to each other. What does that mean? It means that that was the base year. So 2017 was probably the base year, which is why the nominal and the real are identical at that point. So it's not like they did the math wrong or there was something unique that year. It just means that that was probably the base year for this diagram. So somewhere in 2017, I didn't get it quite exact when I was looking at this, pretty close. Okay, alternative method. Based on what you have, sometimes use different things. So we're going to find the real GDP for year 2. And these are the numbers we're given. Remember what the real GDP equation does. It adjusts the current prices to the base year's prices. It says how much would this 25 units of this good be worth if it was in the base year prices, if we adjust this $18 down to this $14 base year. So if you're already provided the base year prices, here's a quick hint, use them. Okay, use the year two's quantities as the market basket, this 25 units. Now, here's the whole equation for this. So we got the equation, price index equals 100 times the market basket in the current year over base year, great. So if I use my market basket of 25 units, because I just need it to be a common number, because the price index identifies the price differences. So I'd have this equation over here. Now mathematically, those 25s cancel each other out. So essentially we're down to 100 times 18 divided by 14. Okay. Equals your price index. So real GDP equals the nominal GDP divided by the price index in hundreds. So real GDP equals the GDP. If you're only given these two numbers, multiply them together is going to be your GDP. So that's where my 25 times my 18 goes. Times my price index, which I just did over here, so that's where I got this number over here. So let's kind of cross some things out. So the 18s cross out, the 100s cross out. So I go to real GDP equals 25 divided by 1 over 14. And I can rearrange that to be 25 times the base year price. Yeah, so we did all of this work to prove that if you're given the base year price, if you adjust $18 down to $14, then you're going to get $14 of the prices. So if you have the base year price, just use those. Otherwise, you have to do all this equation to do that. Okay, that was a long-winded answer to say do 25 times 14 to get it. So that's it. That's a simple way of doing it with everything else. If you're given the base year prices, just use them. And you get the $350 for the base year. Now you try. So year one is going to be our base year. So how would you find the real the GDP price index for years 1, 2, and 3? Just kind of think about what you would do for that. What would be the price index? Since year 1 is our base year, I'm going to just assume I have a market basket of 1. That's the easiest market basket because I do $1 times my market basket, $5 times my market basket. The market baskets cancel each other out. So just assume it's a 1 value. So CPI shows how much the prices have changed from year to year to year. So we're going to use a quantity of 1. So the value of the market basket in the current year divided by the market basket in the base year. That's our equation for price index. So the value of the market basket in year 2 is 5 times 1 is 5. Divided by the value of the market basket in the base year, $1. The price of the good times the one good we theoretically sold would be 1, my base year price. So I get a market basket of 500 and 1,000 for the current ones. And for the year 1, it would be a market basket of, or a price index of 100. So that's where I get these numbers from. Now that you have the price index, was the real GDP for years 2 and 3. First, find the nominal GDP for each year. So for year 2, it will be 15 units produced at a price of $5. If you're only given one price, assume that's all the same good, just for it's an academic practice. So the GDP for year 2 is $75. Then we're going to divide the nominal GDP by the price index in hundreds. So 75 divided by 500 divided by 100 is 5. So I get a real GDP of $15, which makes sense because we already learned my price index is, or I'm adjusting to a $1 value. For year 3, you should have gotten $18 if you do everything else. So make sure this is making sense. Know why we're doing it and why it works. Hopefully it's working. So, alternatively, multiply units of the amount produced by the already adjusted prices. So, for year 2, 15 units produced times the already adjusted price of $1. And same thing, 18 times 1. So, if you're given that, go ahead and do it. Otherwise, you do have to use the market basket and price index and everything else. So, one of the main uses of price index is calculating inflation. So the inflation equation is down below. Inflation percent equals 100 times the price index new minus price index old divided by the price index old. So again, for inflation, we're not always compared to the base year. Okay, and we're seeing what's going on. So here's our equation. So here's an example I just found this online. So we have year 1 and year 2, whatever else it is. So I have my price new minus price old. So 121 minus 112. That's where I got this 9% point change. So I have my price index new minus old is going to be the 9. Divided by the price index old, 112.5, times 100, because that gets this into a percent. So I get 8%. Or for B, 243 minus 225, that's my 18, divided by the price index old, 225 times 100, so 8%. So that's how you get to the inflation. It's a growth equation, so new minus old divided by old times 100. We'll be using that quite a bit for growth changes, percent change in real GDP, for example, for economic growth. We'll use the same concept. Last, there are just some issues with GDP that we do need to acknowledge. It doesn't show non-market activities. If you do work in your own house, it doesn't count, in which case the GDP is underestimated for the amount of productivity, stuff produced, in a given year. Or leisure time, the mental health well-being is not acknowledged. Hey, we have more downtime and we're producing just as much. Okay, mentally we might be healthier, but you didn't get paid for the leisure time. And so again, it's not acknowledged. So it is what it is. Okay, the non-market activity is definitely a bigger thing because stuff is really being produced, but mental health, that is nothing to kid about either. Also, improved product qualities. You have cell phones. Okay, 1984, this thing cost like $5,000 back in 1984, and I'm not actually completely making up that number. Well, now modern smartphones are $1,000 to $1,500, somewhere in that range, and yet they can do a magnitude larger, but dollar value, they actually sell for less. Not adjusted for inflation. We can do that math if we want to now. Okay, but so you don't account for that. You still just see, well, a phone was sold for X amount, a car was sold for X amount, a computer, a bike, a pencil, whatever else was sold for that amount. So you don't get to see that. It's just the number. You also don't see underground economies, the illegal dealings, which, yes, can be some very, very bad things, or it could be things like you tutor on the side. You rascals, you doing underground economies. Yeah, you get paid on the side, under the table, if you will. That's being productive. It's being helpful even, and yet it's not counted in that amount either. So the underground economy, yes, it could be very devious things, or it could be, again, tutoring on the side. Last couple things are the environmental issues. We talked about negative externalities back in microeconomics, and there are some real things. So are we, heavy pollution and everything else, or is it more green and everything? We just get the number that, hey, this amount of farm gear was produced, this amount of energy was produced. We may not see the full impact on that in a very disturbing way. Oil cleanup is really expensive, meaning a lot of money is spent on that service. It could actually increase GDP in a very odd way. So social costs by negative externalities are not associated or highlighted in that. In fact, it could actually increase the GDP for our economy depending on how that all goes. And last is you don't get to know what is being produced. We talk about guns and butter back in the production possibility curve days. So is it wartime goods being produced, or is it peacetime? Is it hospitals, or is it weapons? We just see the number, how much stuff was produced by dollar value. We don't get a list of what was actually produced. We don't see the income distribution. Here we have the Gini coefficient, the Lorentz curve. We have a 0.8. A 1 means completely unequal. So 0.86, that is a really high income inequality. You can see some numbers on here as well. You don't see how the money is distributed. You just see that it exists. So again, the GDP, it has its merits. It has some pros. It's a common number, but there's also some issues with it as well. So hope that was all working. These are the equations you're going to need. So we got real GDP, price index, and inflation rates. So definitely make sure those are making sense. Until next time.